Hi and welcome. This time around I have a quick project. I need to make a jig to hold these parts in alignment. They want to stack up a bunch of these individual plates that make up the stator of a motor, I believe. And they have to be aligned fairly accurately relative to each other. So they can run a weld bead down the side of each set. I believe that stops eddy currents besides combining these guys together. I think that's the point of it. As you can see, there are some holes in the center that you can use to align this. So as a solution, I quickly 3D printed a jig just to test out the idea, and it worked pretty well. So the part I printed is just this round plastic part here. I've got a 5/8 inch pin shoved up the center of it with two ejector pins, since they come in all different sizes. These are 73 thousandths diameter pins, and all you do is you just drop these guys on there and you can line them up. So let me stack a few of these on here so you can show you what you mean about alignment issues. Here you can see them stacked up, and they're lined up pretty nicely, and they don't shift side to side pretty much at all. That's just using two pins on the side for the small holes and one 5/8 center pin. Now, interesting thing, this 5/8 center pin, the hole is actually 0.630 and this is 0.625, so there's 5 thousandths gap there, but the holes have just enough tolerance play that it needed to be that small in order to work. It's supposed to be plus or minus 5 thousandths on this inside, and these are plus or minus 2 thousandths, but I found that the positional accuracy was not great. So in order to get these things to line up, I had to use 73 thousandths instead of 75 thousandths, which the hole diameter is there. And like I said, 0.625 instead of 0.630. So like I said, just two ejector pins and a 5/8 inch pin pressed into this plastic part, and we are good to go. So I'm going to repeat this and make this plastic part out of aluminum, but with a holding portion on it as well. So I need to bore out the center to 5/8 to hold this pin. And then we need to go and drill all these little holes in a bolt circle. I only need two, but I'm going to drill them all just in case I want to go a variety of sizes. We're going to drill and ream them. Here's the plastic part I prototyped really quickly. It was very quick to do. And I printed it almost solid so that I could drill and ream these holes and still have some dimensional stability. The 3D printer I use is pretty darn accurate. So it's usually within 1 to 2 thousandths, which is pretty amazing. So this came out great. This scrap piece of aluminum is almost the perfect size. So we're just going to bore out the middle. Looks like we went just 1/1000th over, which is fine because this is tight anyways. I'm planning on Loctiting this in place, which is perfect because it gets tighter the deeper it goes. So that's good. Just 1/1000th over. All right, so next we're going to reduce this outside here so that the laser welder can get into the edges of the stator and weld it. Let's try 100 thousandths pass, see how that goes. So you notice when I brought the cutter back, it didn't leave a mark. That means I didn't have much deflection in the system. You know, it's pushing the cutter back as it's taking a big cut. If it pushes back too much, then you end up with it's springing back at the end of the cut after the tension goes down. So bringing it back across the workpiece would leave a mark. It did not. That's a good sign. Chamfers. Here's an interesting chip cut off from the part while we're chamfering. Kind of looks like a bracelet or some sort of metal tube. Love the look of metal. Getting the depth set right. Taking 67 thousandths off the back here. Since people are going to be handling this, put a generous chamfer on this side too. And then just for appearance's sake, I'm going to clean up the outside. Completely unnecessary. That just looks nicer. But functionally completely unnecessary. All right, moving on. There's the pin just pressed in. You can see that this pin sticks up just enough to be useful. I might even stick it up like that far there. That seems like it's better because I don't want to be on the radius. That looks better. So we'll have a little bit of insert. I could remove more material off the back, so this would be flush, but this is pretty trivial. Next up, we're just going to drill and ream the 75,000 or 73,000th holes, and we should be good to go. See, you can't read this. I got this within a half a thousandth. Let's see, does that make it easier for you? Now it's more because it just moved on me. I had this dialed in to less than a half a thousandth. By the way, a trick, it was roughing up the aluminum there, so I added a little oil, and it goes around smoothly now. It was catching, so added a little oil, some Vactra in there, and now it's running smoothly. My Blake coaxial indicator ripoff, I'm not sure how accurate it is. I trust this a lot more, and now I've got it within a half thousandth, which was about 4 thousandths different than the coaxial indicator. So I think I got an issue with the coaxial indicator. I'm going to trust this more. We're using our bolt circle setting on the DRO. We're using our tangent engineering quill wheel instead of the arm because we're drilling and it makes it a lot easier. Got the RPM up. Like I said, I marked this out here. I kind of screwed up. I set the number of bolt holes to 8 on the DRO, but when you go full 360 degrees, you got to add one. It's got to be 9 to have 8 holes. So it's set up for 7 holes. So this hole is wrong and all these other marks are wrong. So I got to go back and fix that. Just awesome. So it turns out that if I try and correct it, the second hole is going to be right next to the second hole here, and it's going to totally screw it up. So what I'm going to do is I'm going to do all the holes, and these are all going to be wrong. So instead I'm going to go start 22.5 degrees up, and that should make my first hole different. Hopefully I won't hit any. Well, this guy's going to go in the box of shame. So when I told it to do the first hole 22.5 degrees offset, I thought it was going to offset every hole by 22.5 degrees. Guess what? I should have run through all the numbers because it did not. It offset the first one by 22.5 degrees and put all the other holes right where they would normally be. None of the holes line up. Totally screwed. All right, so here's the fixture done. Here's the 3D printed example that I used to test the idea, and it worked pretty well, so I went ahead and made it out of aluminum. And the parts sit down pretty easily, but don't have too much play side to side, so they can run a bead along the side here, and they just wanted to use their hand to hold it. If they want to do something else, my original idea was to drill and tap the center of this and have a threaded piece that would hold down this whole group of parts, but they said that would slow them down too much. I could also drill out the center of this guy and have a piece that slides down and just presses on these, so you could have your fingers way out here to press on this to hold the whole magilla together while you weld it. They may like that. We'll look at that next. Here I thought I was done, but I disassembled this guy anyways because I thought it'd be really nice to make an aluminum piece that pressed over this pin here just to hold these plates aligned and all together so that you could weld them accurately rather than using your finger. It seems like a bad idea, the finger idea. So I heated this up enough to melt the Loctite or break down the Loctite, I'm not sure which it does, and not enough to damage the tempering on this hardened pin. And next we'll make the piece, the cap that fits over there. Just parting this guy off. So we're making the part again because that's what this project's all about, doing things twice. Much thinner profile this time. There's the previous one. All right, so we're going to assemble this guy. Last time I had a hard time getting the Loctite deep enough in the holes to hold these pins in place reasonably. So this time we're going to take a syringe and inject some down into the hole. This is very viscous. I actually may not have gotten any in the syringe. I didn't count on that bit. I think the wicking Loctite might have been a better choice. Well, I think I got some in. And now they're pistoning out. So I guess the Loctite did make its way in. So I've cleaned these up. I pushed them down and it pistoned out a bunch of the Loctite. As you can see, there's still a little bit more coming here. For this viscosity Loctite, you really can't use a syringe because it's too tight. Okay, I think that'll be good. And just to verify this, so I'm putting the test stators here on the fixture so that I can verify that I will be able to hold them down with this new piece I made, since I went to a lot of effort to undo stuff I'd already done. All right, and then this guy fits here, and now you hold it like this and you are good to go. I think that's a big improvement. This piece just sticks up a little proud of the pins themselves, so you don't have to push on the pins. You can set the flat part here on a surface to guide where you're going to be doing the cutting, and you can get your laser cutter in here. Now, by looks of this, I could have reduced this distance here and have this closer so there wouldn't be so much temptation to tilt. But I think overall, this is a pretty darn good fixture, and I think it should work for them well. Well, that's it. Thanks for watching. Hope you find it useful. Hope to see you next time.